Good morning, everyone. Thank you for applauding before I've even started speaking. I love your optimism. And thanks for coming to listen to me talking about FastAPI for the next 25 minutes. Could everybody put their hands in the air, please? Okay, thank you. Now, put your hand up if you've heard of FastAPI. Keep your hand up if you've used it in production. Okay, cool. Thank you. So, Um, I came across FastAPI about 4 years ago, and I've been working with it solidly for about the past 3 years. So I'm going to give a quick introduction and overview of FastAPI just to show what it looks like. Then I'm going to talk about um, things that have really helped, features of the framework that have really helped. And then we're going to talk about a few things which have not been as helpful, things I've had to work around. And there are going to be 25 slides. We're on number 2 already, so don't panic. If you have never used FastAPI, then you will have used Flask, you will have used Express or Sinatra. And these are all micro frameworks. They've got a very similar design. They map a URL path and an HTTP method onto a function that handles that. They take path parameters as input arguments, and in FastAPI, they take the request body as an input argument as well. So yeah, if you've not used FastAPI, then it should look quite familiar to you. This is a very basic application. I'm sure we can all understand what's going on here. We're creating an application. We're mapping the get HTTP method to the slash path, and we're returning the string hello world as a classic example. So things that have really helped. Type hints. Who uses typing religiously in their Python code bases? So there's quite a few people. Who sprinkles types through occasionally and then stops running the linting when they run into problems? Yeah, yeah, definitely. So async support as well in FastAPI, that's great. Dependency injection, that is awesome. Really like that. And then the testing support as well is really cool. So this is our basic app again, but we've added a little type hint on here. Just to say that this returns a string. So the first thing that struck me about FastAPI was the use of types. And it was the first place that I'd actually seen types being used for something other than just that kind of linting step that you're able to turn off when things get too difficult. And when I first tried to use types, I did run into a bug with JSON typing, I think it was, and just stopped running the type validation because everything was working other than that type validation. So it didn't seem to be giving me anything particularly valuable. That was quite a few years ago. So seeing FastAPI was really cool, and you can go even further. So this only returns hello world, so you can actually annotate it with the literal hello world to say this is all that it returns. And doing stuff like this, it's given me a better understanding of the Python typing ecosystem, which is very cool, and it's still evolving quite a lot as well. Each new Python release, we heard about the roadmaps and the release schedules in the keynote this morning. Each new release has improvements and updates to the typing package, so that's really cool. But what does that give you? What do the type annotations that you're adding in there actually give you? So you get an automatic schema for your API. This is OpenAPI 3.1 compatible. Tells you about all the paths, tells you what methods are available, what the responses can be, what the schema of those responses can be. It will tell you what the schema of any inputs can be. Really cool. Obviously, I don't really look at this very often because I can't really parse that in my mind. I'm sure some of you can do, but what you can do is plug it, or what happens automatically is that this gets plugged into a Swagger UI. So if you go to /docs on your running application, then you get these comprehensive API docs. This is just for our very simple application. So it's just got this root and it just returns hello world. But this is available to us without us having to do any extra work. That's really cool. You can get redocs to, I think at /redoc. I think I've only ever looked at that a couple of times since using FastAPI. But this is great. This works really well. And I'm not that keen on writing documentation. I mean, I know most people love it, but I don't like it that much. So having these comprehensive API docs is really awesome, and being able to give that to your clients without having to do any extra work is amazing. And so you can make the typing more complex, of course. Pydantic is integrated very tightly with FastAPI. Who's got experience with Pydantic? Great. Yeah, really, really nice library for defining your data, and it validates your data. So we've got a slightly more complicated example here, mapping the put HTTP method and this path, which has a path variable in. You can see that name gets injected and it's validated as a string. And then because it's a put, we've got a body, and that's this resource properties. We've called it properties. And that has two fields in it, size and tags. Tags is a dictionary. Size is an int. We've used this annotated type. Has anybody seen the annotated type before? So this allows us to attach some extra metadata to a type. And Pydantic uses this, so FastAPI and Pydantic use this for attaching things like validations. So you can see we've used the field function from Pydantic, and we've given lower and upper bounds for this integer. So it's going to be greater than 1, it's going to be less than or equal to 1000, and we've put that onto the integer using this annotated type. So by the time it gets to this handler function, that's all been validated for us, and then we're returning this resource which is constructed from these things which have been passed in. Obviously, this is a very contrived example. This isn't something I would be doing in production. But what the upshot of that is that you've got a very comprehensive contract now for your API. When you get back into the Swagger documentation, you can see that name is validated as a string there. And these properties on the request body, they've got validation on as well. And then the responses have a schema. It tells you what the response is actually going to look like, what you can expect to get back. And we've got this extra response here, which we haven't configured, the 422. What that means is that anything which doesn't validate against this input schema gets automatically rejected before you even get to your handler function. So you get this 422 validation error back, and it tells you what has gone wrong and where this validation has failed. So that's awesome. That's really cool. That does a lot of the work for you. You think about what your contract actually needs to be, and that does a lot of the work for you. So asynchronous I/O was the next nice feature. FastAPI, as its name suggests, is designed to be fast, and it does that using an event loop for non-blocking asynchronous I/O. I first heard about this in Node.js in JavaScript when that became popular, and that was that asynchronous I/O, non-blocking I/O, and event loops were discussed a lot more around that time. And basically that means that when you have these I/O operations, this single-threaded event loop doesn't block the other request. That I/O gets sent off to do its work, but the event loop continues to process other things. So if we have a look at an example here, this is using an asynchronous HTTP client to go off and get some information, and then it formats that and returns it. But you see where we've got the await, then that is where the event loop gets unblocked. All the time we're running other Python code, the event loop is actually blocked. And so we have to be a bit careful about not blocking that for too long. But at the point that we await, that goes off to do its thing, and the event loop can handle other requests. So that can make your web server very performant with only a single process. FastAPI under the hood uses Starlet, which is providing that asynchronous I/O. Dependency injection was the next feature, and I do love this feature. This is no exaggeration. Dependency injection is awesome. So we've already seen that in our handler functions, we had path variables, we had request bodies passed in as arguments. We can also get our dependencies passed in as arguments as well. So again, we see this annotated type, and we've got a database class that we need to get, and then we're using this depends function from FastAPI, and we tell it that we need to use the getDatabase function, and that sets us up our database connection. It returns this database class. We don't need to worry too much about how that happens, but by the time you get into your handler function, you've got access to this database variable, and you can query your users and return them. That lets us decouple our code really nicely, and these dependencies get cached by default, so it can be quite performant as well. They can be asynchronous, and they can be generators as well. So this allows us to set up and tear down our dependencies if we need to. And this is the weather example that we saw from earlier, but with injecting this HTTP client. So that just separates out the logic from the dependencies that are being used. So this allows us to organize our code in a much nicer way. So going further with this example, we separated out the logic into a separate service, and then we actually got a dependency on this service so that the HTTP endpoint is just handling the calling of the service and the formatting and response of that data. So this really allows us to decouple all our HTTP stuff from our business logic. And we can go even more granular. So you can have multiple levels of dependency injection. So the weather service actually depends on this HTTP client. So you can refactor that out, and you can reuse these dependencies at different levels. So if anything else needs the HTTP client, they can get it injected as well, and you just have this one provider for this dependency, and this separates everything out very nicely and keeps it really clean. So testing as well. FastAPI has a built-in test client. You import that and you pass your application into it. That just allows you to call the application and do validations on those responses. Very handy. And we see the dependency injection coming in here as well. Dependency injection is great for testing. We've already talked about how we can decouple our HTTP handling from our business logic. This allows us to override the weather service that's being used in that HTTP endpoint with a mock one, and we just define the behavior that we expect from that, and then we can just test the behavior of the endpoint. And because we have different levels of dependency injection, then we can also have different levels of testing. We could mock the weather service completely if we've got some stuff that we want to test in the endpoint and make sure that that is happening correctly. Or if we want to mock the HTTP client, then we can mock that whole journey and have it more of an integration test. So really powerful. Love the dependency injection. I think is a really great feature. So this isn't part of FastAPI, but this is super useful. Schema Thesis, which is built on top of another library called Hypothesis for property-based testing. What you can do is you can plug your application into Schema Thesis. We've got a bit of setup and teardown, which again is just using this dependency injection. And then you can call each endpoint on your application, and that will generate a load of different inputs, and it will validate that the inputs that it generates according to the schema are handled properly, and any responses that come back are in the schema and are valid according to the schema. So that's really awesome for catching any problems that you might have done in your type annotations, making sure that that documentation, that automatic documentation, is actually correct. So things that haven't been so great, things that have tripped me up. Synchronous calls in some of those async endpoints. Running multiple worker processes, for it, and generating clients from that API schema. So synchronous calls. We've got this async endpoint, but it's calling something which is doing a blocking operation. And that's going to block the event loop. We've already talked about that, how when we're running Python code, that blocks the event loop. So if that runs for a long time, then it's going to block any other requests from being handled on that event loop. So you can end up having very slow responses from your application. And if you've got quite a big application, it's not always very clear where that slowdown is coming from, because it slows down everything, and so it's kind of hard to diagnose. So if you don't mark it async, then FastAPI will actually run it in a thread pool to avoid that. But if you accidentally block the event loop on an async endpoint, then that can be difficult. So you can detect problems. There's no built-in instrumentation in the Python event loop, but you can measure this delay in the event loop with something like this. So the important bit here is this loop call later in the run method, and this runs this handler which just takes a start time and then measures the current time, takes off the interval that it's running on, and it finds when should this thing have started, when does it actually start, what's the delay between tasks being picked up. This logs it, but it could be a metric, could be pushed into Prometheus, and this is just taken from Stack Overflow. So I've put the source down there. And you can integrate that into FastAPI with this lifespan function. So this is an async context manager, and it runs something when the app starts up, and it runs something when the app stops. So while the app's running, this event loop monitor is running continuously and telling you what the lag is every 1 second, whatever you set the interval to. So that's pretty handy. Worker processes. So running inside a container. We're probably all running inside containers these days. The FastAPI docs recommend using UVcorn, which works really well. It recommends when you're running inside a container using a single worker thread and letting Kubernetes or whatever container scheduler you've got, whatever container orchestrator you've got, handle scaling that out for you. But there's obviously a penalty to pay for that, because if you're running any sidecar containers, if you're running any other things, or if you're scaling that up, there's a time penalty. So you may want to look at actually running multiple worker threads inside a single container. And I tried that, and it does work, and it works quite well. One thing which can then trip you up is your resource requests and limits for your containers. Because you're running multiple processes inside there, you're using a multiple of those of the resources. So you need to do some kind of tweaking on there, and you can do that inside Helm using the mole function. So it can be done, but I actually backed out of that for reasons which I'll go into in a minute. Prometheus instrumentation, really easy to add into your FastAPI app. This is awesome. This gives you some Python metrics on garbage collection and memory usage. This gives you request counts and request times straight out of the box just with that single line of code. Really great. However, when you run multiple worker processes, that doesn't work in the same way, and you end up with false counts. And there is a workaround for this, but it was more involved, and so I just went back to running a single process inside those containers because that was much simpler. But there is a workaround for that, but I haven't tried it, and I've just gone back to letting Kubernetes handle the scheduling of multiple processes. So the next thing was SDK clients. So we've got the types, we've got these automatic documentation for the API, which is really awesome. In theory, we can generate a client from that as well. And that can work really nicely. But there are several different versions of the OpenAPI schema, 2.0, 3.0, and 3.1. Not all of the generators support all of them. And so we've already seen that FastAPI generates a 3.1 compliant schema. In this particular client generator that I favor, which is from OpenAPI tools, this typing combination, an optional something, I've used int here, but I think it works with anything. I think it doesn't work with anything. An optional something with a default of none causes an exception when you're actually trying to generate the client. So that was a real pain. And actually getting this kind of automatic stuff, and FastAPI works so well and generates all this stuff for you, to then plug it into something else and find that it doesn't work was a bit of a pain. But this issue is actually fixed in a later version of the OpenAPI tools generator. But obviously you're then dependent on something else to fix that. So in summary, I love FastAPI. I'm all in. The typing and dependency injection are definitely my favorite features, and they make up for my reluctance to write any kind of documentation, and they satisfy my desire to test and to decouple my code. And this data validation, which is actually provided by Pydantic, but this integration with Pydantic is really cool. It's not perfect, but you've got more of a guarantee that by the time you actually get into your handler function, then that data is in the right shape. And so your validation can be much more focused on your actual business logic. So that's it. That's my thoughts on FastAPI. Thank you.